let's look at a limit. This is probably a limit, something you would have seen back in Cal 1. Evaluate the limit as x goes to 0, e to the x minus 1 minus x over x squared. So whenever you have a limit, you usually start by plugging in the numbers, right? What do I get for the numerator if I plug in 0? 0. What about the denominator? 0 as well. So I get 0 over 0, which means we usually use L'Hopital's rule. But I'm going to show you another way that we could do this. If you look, everything is a polynomial except for this e to the x. So what I'm going to do is I'm going to write down the Maclaurin series. I'm taking the limit as x goes to 0, so I'm going to write down the Maclaurin series for e to the x, which we just used. It's the sum, n equals 0 to infinity, x to the n over n factorial. And for this, I'm actually going to go ahead and write out some of these terms. So I get 1 plus x over 1 factorial plus x squared over 2 factorial plus x to the 4th over 4 factorial. So I write out some of the terms. And now because this Maclaurin series represents my function, I can replace e to the x in the limit with this Maclaurin series here. So I'm looking at the limit as x goes to 0, e to the x minus 1 minus x over x squared. I can now drop in my Maclaurin series. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus dot dot dot, and then I have minus 1 minus x. I'm running out of room here. I have to shift it over a little. Minus 1 minus x over x squared. And it doesn't seem like this is any better, but if you look now, there's a 1 and a minus 1. They cancel. There's an x and a minus x. They cancel. So I got rid of those other two terms for me. And then what that gives me, the limit as x goes to 0, x squared over 2 factorial plus x cubed over 3 factorial, all divided by x squared. Okay. And now this x squared will divide into each one of these very nicely. It's just going to reduce my powers down by 2 for each one of these terms. So now I'm looking at the limit as x goes to 0, 1 over 2 factorial plus x over 3 factorial plus x squared over 4 factorial. And now what happens when I plug in 0 in place of x? You get 1 over 2 factorial, because all the other terms are zeros. So you just get 1 over 2 factorial, or 1/2.
It wouldn't be if it wasn't approaching 0, then you couldn't use the Maclaurin series, right?
You wouldn't, yeah.
Okay. So you can only
Well,
use
what's our radius of convergence for? Yeah, I think if it's taking the limit as x goes to a, you would want to do the series centered at a. So you want to do Taylor series centered at a. Exactly. And if you did the L'Hopital's rule, you would get the same answer. 1/2. Okay. It would just take a couple iterations. And this seemed, I don't know, for me the first time I saw this is crazy. If the way we calculated this limit before, the only way I could do it was taking derivatives using L'Hopital's rule. But now I can use this series, I plug it in, my terms cancel and everything simplifies so nicely that now I can just plug in 0 and be done. So it's a much different process, takes time to like understand, but what's going on is, again, you're representing your function, in this case e to the x, with a polynomial, and things become so much nicer when you think of things as polynomials. They're like the nicest functions you can have, okay?